Tonight is the night. Within hours, 3I, Atlas, the strange, emerald glowing traveler from beyond our solar system, will glide past Mars. What happens next could reshape how humanity understands comets, interstellar visitors, and possibly its own place in the universe. This is not a drill or a simulation. It's the moment when observation meets mystery, when months of speculation will either collapse into simple chemistry or evolve into something far beyond expectation. From its discovery, 3I, ATLAS has behaved like nothing astronomers have ever recorded. Typical comets brighten and fade predictably as sunlight vaporizes their icy surfaces. But this visitor, refuses to obey those rules. Its glow pulses in waves, brightening and dimming in ways sunlight alone can't explain. Spectral data shows that its atmosphere is dominated not by water vapor but by carbon dioxide. The dust around it moves unusually slow, heavy, and uniform. And that shimmering green halo, its defining feature, doesn't match any known chemical signature in nature. Even seasoned scientists are beginning to wonder if something more deliberate may be at play. Now, as 3I, Atlas closes in on Mars, all speculation gives way to evidence. Earth will soon lose sight of it behind the Sun, leaving only the robotic eyes around the red planet to watch the encounter unfold. Mars Express, MAVEN, and the Trace Gas Orbiter have been reassigned to constant surveillance. If weather and power allow, even surface rovers will turn their cameras and sensors skyward, searching for electromagnetic or luminous anomalies. For a few tense days, Mars becomes humanity's only outpost facing an interstellar visitor. Skeptics remain. Some researchers argue that 3I, ATLAS is simply a natural comet from an extremely cold, carbon-rich system, its violent flares caused by trapped gases bursting free. Its flat, steady orbit could just be coincidence. Its pulsing light, an illusion of reflection or rotation. But doubts persist. Because three details stand out: its path, unnervingly flat, as though it's traveling purposefully along the same plane as the planets. Its pulse, rhythmic bursts of brightness, matching subtle accelerations recorded by multiple observatories. Its makeup, traces of rare metallic compounds that don't fit any known comet model. Each might be explainable on its own. Together, they form a pattern that feels guided. As it sweeps past Mars, scientists will focus on three kinds of data. Fragmentation. If it breaks apart, the shape of its debris could reveal whether it's just ice, or something structured inside. Trajectory shifts. Even minor changes after a flare could suggest propulsion or control. Spectral emissions. If radiation or charged particles appear that aren't typical of vaporizing ice, explanations will need to evolve fast. Mars will act as both observer and experiment. Its thin air, patchy magnetism, and fleet of orbiters make it a perfect testbed. A single fragment grazing the atmosphere could create brief auroras, magnetic ripples, or chemical traces, all detectable from orbit. Data will come in late, scattered and delayed by solar interference, but every bit will matter. Spectra, isotope ratios, dust grains, all pieces of a cosmic puzzle. Inside control rooms on Earth, the tension is electric. Engineers double-check backup channels. Scientists monitor overlapping telemetry streams. Amateur astronomers across continents prepare to capture any flicker of change from their backyards. Because sometimes, the first sign of discovery doesn't come from billion-dollar hardware, but from a single telescope pointed at the sky by someone who refused to sleep. But beneath the excitement lies a deeper concern: contamination. If 3I, ATLAS carries complex organic chains or unknown molecular patterns, fragments reaching Mars could complicate future life detection missions. Differentiating Martian biology from alien material could take years of analysis. That's why teams have enforced strict data custody protocols, time-stamped captures, redundant spectrographs, and verified transmission logs. Still, a question lingers. If this object reveals signs of design, who decides what happens next? Tonight, scientists across the world stand divided, their eyes fixed on the same emerald speck cutting through the darkness. Every lab, every observatory, every orbiting instrument is tuned to one question. What is 3I, ATLAS really? Three possibilities dominate the discussion tonight. Three paths that could change everything humanity knows about the universe. The first is the natural scenario. In this version of events, 3I, Atlas is no more than a strange, beautiful comet, a wanderer born in the deep cold between the stars. Its violent flares, its eerie rhythm, its green glow, all could be explained by exotic ices, ancient cosmic chemistry, and the laws of physics stretched to their limits. If this proves true, it would still rewrite what we know about comets. It would mean that some worlds form with entirely different blueprints, rich in carbon dioxide instead of water, hardened by centuries of cosmic radiation. Even as a natural object, 3I, ATLAS would be a message from another stellar nursery, a frozen letter written in molecules instead of words. The second is the violent breakup. In this outcome, the comet doesn't pass quietly. Instead, it shatters near Mars, scattering debris across the planet's orbit. Fragments the size of buildings could streak through space like shrapnel, threatening orbiters, sensors, and communication relays. For a few tense hours, Mars could be surrounded by a glittering ring of dust and metal, a temporary halo of destruction. Scientists call this the worst-case scientific miracle, dangerous, but full of clues. If it happens, every fragment, every glowing trail would tell a story about the comet's internal structure, its history, and maybe its origin system. And then, there is the third scenario, the anomalous event. The one that scientists discuss in hushed tones, avoiding the word they don't want to use. In this case, 3I, ATLAS would act with coherence, its light pulsing in perfect rhythm, its trajectory adjusting as if guided by intent. Emission patterns might appear structured, like a transmission coded in light. If that happens, the conversation shifts forever. Because nature can create beauty, chaos, and complexity, but not coordination. A synchronized signal would mean something else. It would mean design. And that single word, engineered, would echo through every observatory, every control room, and every human mind. Already, the James Webb Space Telescope and Hubble have taken their final readings before the sun's glare blocked their view. Now, all eyes turn to Mars, humanity's silent guardian on the edge of this encounter. Its orbiters, landers, and rovers are ready, scanning the skies for flickers of change, listening for whispers of radiation or magnetic flux. For the first time in history, an entire planet has become a cosmic observation post, our outpost between curiosity and the unknown. And while data streams across deep space antennas, the world waits. In living rooms, observatories, and deserts, millions watch the same sky, a faint green glow sliding past a red world. It's a sight both beautiful and haunting, a reminder that the universe still writes stories no human has read before. Across social media, theories explode: alien probes, self-replicating machines, messages from lost civilizations. Some see it as proof that we are not alone. Others see it as a cosmic warning, a reminder that intelligence, wherever it exists, may not think as we do. But science moves slower than imagination. It must. Because extraordinary discoveries demand extraordinary proof. And that proof takes time, patient, careful, deliberate time. When dawn finally comes, one of two stories will be told. Either 3I, ATLAS was a relic of alien chemistry, a natural traveler bearing secrets of distant suns, or it was something else entirely, something constructed, controlled, and possibly aware. Whichever truth emerges, one thing is certain. The universe has grown just a little larger. And in that expansion, our understanding, our certainty, has grown smaller. So tonight, look up. Not for answers, but for the questions that make us human. Because somewhere between Mars and the Sun, a green light moves through the dark, ancient, indifferent, and perhaps, alive. It crosses the sky not to prove or disprove anything, but to remind us that the story of the cosmos is still being written. That every comet, every signal, every flicker of light carries a possibility. And that our greatest instrument isn't a telescope or a probe, it's curiosity itself. Whatever 3i, ATLAS turns out to be, it has already done something remarkable. It has united a species in wonder. It has made us all look beyond the noise of the world, toward the quiet of the stars. And somewhere out there, in the vast dark, it drifts on, the green wanderer, the silent messenger, the question we still don't know how to ask. Because the cosmos is far from finished with its surprises. And tonight, under that emerald light, humanity remembers that curiosity is not just how we explore. It's how we survive.